In this video, we're going to look at some multi-step algebraic equations that either have no solution or have infinite solutions, meaning that either there is not any number that can replace the variable to make the equation true, which would classify it as a no solution, or any number can replace the variable and make the equation true, in which case we would identify it as an infinite solution. So we start off here with our first example, and I know that when I see parentheses, I have to deal with those first. So in order to eliminate the parentheses, I have to use the distributive property, and I multiply the value outside the parentheses by both terms inside the parentheses. And when I do that, I end up with a new expression that looks like this. My next step is to look at each side and see if I can simplify it in any way. And I see on the right hand side here that I have like terms. I have -2 and -3. So I'm going to combine those together, and that makes the equation say 4x minus 5 equals 4x minus 5. And this is pretty cool because if I look here, I see that both sides of the equation are exactly the same. So what would happen is if I were to replace each of these x's with a number, I would always get the same result on each side. And when that happens, we say that there are infinite solutions. So the main characteristic that I see when there are infinite solutions is that both sides are identical. If I don't notice that right away and I decide to continue the process of solving my equation, I'm going to notice that we run into something that we typically would not. And here's what happens. So after I distribute to eliminate the parentheses and I combine my like terms, I would then work to move my variables onto one side of the equal sign. So since I'm dealing with a positive 4x, I would subtract 4x. And then I would come to the other side and I would subtract 4x. And you'll notice what happens is our variable actually cancels out on both sides of the equation. And it leaves me with my two constants, -5 equals -5. Now, since that is a true statement, that will also lead me to believe that there are infinite solutions. Here's our second example, 4x plus 2 equals 4x minus 5. And here I don't see any parentheses, so I don't have to use the distributive property, and there are no like terms that can be combined. So I'm going to start solving the question. And I know that the first thing I have to do is get my my variables onto the same side. So seeing as this is a positive 4x, I'm going to subtract 4x. It eliminates on the right side, so I'm going to cross it out. And I'm going to come over and subtract 4x on the left. And very similarly to example 1, you're going to see my variables have canceled out. So what I'm left with is 2 equals -5. And now we know that that is not a true statement. What this tells me is no matter what number I put in for x, these two sides will never be equal to each other. And when that happens, we say there is no solution. So some characteristics that tell me there's no solution. We have identical variables and coefficients on both sides, so they cancel out. So the variable will cancel out. And the other characteristic is that you will be left with a false equation, because obviously 2 does not equal -5.